Okay, this is a volume of revolution revision question for us. It's an exam 1 style question, so let's get straight into it, guys. The region in the first quadrant enclosed by the x and y axes, the graph with equation y equals minus a half log of x base e and the line y equals a, where a is positive, is rotated about the y-axis to form a volume of revolution. In part A, express the volume of revolution as a definite integral. In part B, calculate the volume of the volume of revolution in terms of A. And finally, in part C, find the value of A if the actual volume is pi over 4 minus pi over 4e to the 8th cubic units. No problem, guys. Let's get our heads together on what this graph is going to look like first, I think. I've drawn a little graph for you. If it's minus a half of log x, then it's basically an upside down one, isn't it, right? Reflected about the x-axis, so it's reflected top to bottom and bottom to top, alright? That's the first bit. We know it's rotated around the y-axis, so let's get our head clear on that. Now, the region that we're rotating is enclosed by the x and y axes, the curve itself, and the line y equals a. Alright, I think we've got it nailed, haven't we? And of course, in this type of volume of revolution, the little rectangles that we form and find the integral of as the widths of these things approach 0, the height, inverted commas, close inverted commas, of the rectangles are really the horizontal distance x, if you like, and the little widths of them are the delta y's, okay? And those little rectangles, there'll be an infinitely large number of those spreading from y is 0 up to y is a. So we really need to do the following integral as the volume of revolution. V is pi times, please don't forget the pi, x squared, because the radius of the circle that we're going to make around here, and then multiply by delta y to make a little disc shape. The radius is x, alright, so it's pi x squared dy from y is 0 to y is a, alright. Now what we've got to do is we've got to get x, this x, in terms of y, because we're integrating with respect to y. That should be pretty easy if we just keep our heads together, realising that this is the function up here. So we've got y is minus a half of log of x base e. Let's make x the subject of that, okay? Therefore, minus 2y is log of x base e, and therefore x is going to be e to the minus 2y. That's what we need. Okay, now we're going to plug that x into our integral up here, and we'll be laughing, guys. There it is. Ain't it grand? Okay? So if that was e to the minus 2y, if you square that, of course, it's e to the minus 4y. So there's your integral, and there's your mark, done and dusted. Now, what have we got to do for part B? Calculate the volume of revolution in terms of A. Oh, no problem. Just evaluate the integral, the definite integral. That's as easy as pi. So, my oh my, let's do B, and there it is, okay? You know how to integrate e to the minus 4y. It's 1 over minus 4, e to the minus 4y, and of course the whole thing's multiplied by pi. And we're integrating between 0 and a, so let's do that now. Alright, now, that's what I get. If you do a, if you put a in there, it's minus pi over 4 e to the minus 4a, then it'll be plus, with a 0 plugged in there, plus pi over 4 e to the 0. Of course, e to the 0 is 1, so you get that. Let's just pretty that up and put it in a bracket with the pi on 4 taken out. And there is the answer. Beautiful. Beautiful, guys. Now, part C, we're on a roll here. Find the value of A if the actual volume is that. Well, that's going to be really easy. Here you are. We've got V is actually this actual value, and it's this in terms of what we just got up here in terms of A. Now we've just got to chug through the algebra and work out what A has to be in order for them to be equal, for this to equal that. Plug out, cross out those, first cab off the rank, and then re-express that left-hand side as e to the minus 8, so it's minus pi over 4 e to the minus 8 equals minus pi over 4 e to the minus 4a, and therefore 4a equals 8, and therefore a equals 2, and we are laughing. and we're ready to go on to the next question. Alright, volumes of revolution, they're no problem. Just know what you're doing, practice them and get good at them, and you'll be fine. See you soon.